So we've been doing area under the curve since Unit 6. This is something we've been doing for a while. So this isn't like new information, just kind of adding on to what we already know. Instead of just having one graph, we're now going to have two graphs. But you really did before as well. It's just that one of the graphs was the x-axis, so we never really mentioned it. Like we had a graph and then we had the x-axis as the other graph, sort of ignored it. Now you're going to have two individual graphs, right? And so the area is going to be, from wherever to wherever your boundaries are, wherever their intersections are. And it's going to be the upper graph minus the lower graph. I hope that makes sense logically, like that sits well with your common sense. That's going to give you the area in between. It'll be the upper graph minus the lower graph. Now, sometimes the whole picture is sideways. And here's the question I get asked all the time is, Cole, how do you know when it's sideways? And I don't have a great answer for that. You kind of just need to look at it and see what you've got. I know you all hate that answer, but it's true. Sometimes you get sort of a hint in the equations, and I'll show you. You can use the equations to help you. But if it's sideways, instead of dx, it's going to be dy, and it'll be the right graph minus the left graph, which if you turn your paper, 90 degrees counterclockwise, it would be upper minus lower. Or you could think of it as right minus left. It's still the bigger one minus the smaller one. Right, so we're just going to practice a few of these. Again, it's not like new information. We're just kind of adding on to what we already know. We're going to have a second graph. So you need to be able to graph. That's a skill that you need in order to be able to get through this. Find the area bounded by. All right, so this is a parabola that moved up to. So we're going to go up to, put a point. And then we need some points on either side. You have to be pretty particular about your points because we're going to have to get the intersections of these graphs exactly. All right, so if you plug in 1 to that, you're going to get 3. Same point on the other side, since it's a parabola. And if you plug in 2, 2 squared is 4, plus 2 is 6. So we're going to get 2, 6. And so here's our parabola for that first. All right, and then the other graph, the next one, y equals negative x. So that's going to be a line, it's linear, it goes through the origin, and it's going to have a slope of -1. So we're going to go down 1 over. All right, and then we've got x equals 0, so that's just vertical line at 0. And then x equals 1 is a vertical line at 1. So this is the area that we are going to find. And so when we set up the integral, it's going to be from 0 to 1. This one was kind of spelled out for us because you have x equals 0 and x equals 1. So we're gonna integrate from 0 to 1. It's like you're sweeping left to right. This is all the area that we want to get. And it's the upper graph minus the lower graph. So the upper graph is this x squared plus 2. And then minus the lower graph, which is the negative x, and then dx. I realize those negatives are going to cancel, but in your notes, write it out that way because I want you to remember that it's subtraction. We're going to fix it in the next step. Now here's the rule of thumb for these that I usually say. If it seems reasonable to work out by hand, work it out by hand. A lot of these will be non-calculator, and I don't want you to lose your skills with doing an antiderivative. You need to be able to work these out by hand. Now, if it seems totally obnoxious, then go ahead and put it in your calculator. I think a lot of the ones we do today are going to be all right, though. See, this isn't going to be too bad. This antiderivative will be 1/3 x cubed plus 2x plus 1/2 x squared, and then such that 0 to 1. Yeah, and this kind of does look like a trapezoid almost, except that this side is bent. So that's why we would not have been able to do it with a trapezoidal formula because this side was curved. It almost, if this side was also linear, then yeah, I guess we could have done that. All right, so this is upper boundary minus lower boundary. And so if we plug in 1, that's going to give us 1/3 plus 2 plus 1/2. If we plug in 0 to all these x's, they're just all going to be 0. That's just all nothing, which is actually kind of convenient. And again, if it's free response, you can stop there. If it's multiple choice, you'd have to keep going. So let me keep going here. We need a common denominator for 3 and 2. That would be 6. So this is 2 6. 1/3 would be 2 6 plus a whole 2 would be 12 6. 12 divided by 6 gives you 2. And then a half would be 3 6. So what does that add up to? 17 6 is our final answer. All right, so let's try another one. I'm going to have to keep things going here to make sure we finish. All right, so we've got our first graph, 2 minus x squared. So it's a negative parabola. It's upside down, and it moved up 2. We're going to go up 2. Put a point, and it's going to go like this. But I need to find the points real specifically because we need to get the intersections here. So let's try to plug in 1. If you plug in 1, you're just going to get 1. And if you plug in 2, 2 squared is 4. 2 minus 4 gives you negative 2. And then again, same point on the other side since it's a parabola. So we've got that. And then we've got f of x equals x. So that's a line that's going to go through the origin and have a slope of 1. So you're just going to go up 1 over 1. And here is the line. So this is the area that we're trying to find. So the boundaries are a little bit tougher for this one. For number 1, it was real obvious. It was 0 to 1. It was pretty much like spelled out for us right here. This one, you have to look at the intersections. So I'm going to throw this question at you guys and see what you come up with. You can write it privately if you're not sure, but I want to get some answers. Where do you think the boundaries are going to be on our integral? It's going to be from where to where? And good, you guys jumped on that. Good. So from -2, which is right there, to +1. Nice job, guys. And again, it's like you're scanning left to right. So you want from -2 to +1. It's going to be the upper graph minus the lower graph. So the upper graph is this parabola. So 2 minus x squared minus the lower graph, which is x, and then dx. Again, this one's not going to be bad to do the antiderivative. So let's go ahead and do that. I don't want you to lose your skills. All right. So it'll be 2x minus 1/3 x cubed minus 1/2 x squared, such that -2 to 1. We're going to do upper boundary minus lower boundary. This one's going to be a little bit messier with the fractions because one of the boundaries isn't 0, but we will persevere. All right. So if we plug in 1, that's going to give us 2 minus 1/3 minus 1/2. And then if we plug in -2, that's going to give us -4 plus, because the negatives are going to cancel here, -2 cubed would be -8. Again, negatives cancel, so this will be +8/3. And then -2 squared will be 4. Half of that is 2, so -2. Here's what I would do if you had to get through this. If it's free response, by all means, stop there. But if it's multiple choice and you don't have a calculator, you got to figure this out. So I'm going to distribute the negative, because oftentimes some stuff will either combine together or cancel out. And if you can do that, that's great. If you can get things to combine or cancel out. So let's combine up all the whole numbers. We have 2 plus 4 plus 2. So 8 for that. And then let's look at the thirds. We have -1/3 and -8/3. This works out kind of nicely because that would be -9/3, which is -3. And then the only other thing is the -1/2. So that would be 5 minus 1/2, which is 4.5. Or 9 halves if you want the fraction. All right, next one. Find the area bounded by all those things. Okay, so we're gonna need to graph this thing. So let's start trying to plug in some numbers. I would start with small thing. Like let's start with 0. If you plug in 0, you're gonna get 3. And this is cubic, it's cubed, so I'm expecting it to wiggle, like it's gonna do something like this, right? So we need to plug in enough points until we get all those turnarounds. So let's try 1. You plug in 1, let's see, that'll be 1 minus 3 would be -2, minus 1 would be -3, plus 3 would be 0. All right, now let's try 2. Let me write these out so that we can see what we're doing here. All right, so if we do 2, 2 cubed is 8. Here, 2 squared is 4 times 3 is 12. Then minus 2 plus 3. So that's going to be 8 minus 12. That'll be -4 minus 2 will be -6 plus 3 would be -3. We get 2, -3. It still hasn't turned around, right? Let's try 3. 3 cubed is 27. 3 squared is 9 times 3 would be 27. So that's kind of nice. Those cancel out. Minus 3 plus 3, that's going to be 0. So 3, 0. And then I don't even want to try to plug in 4. 4 is going to be like way up here somewhere. If you do 4 cubed, that's 64. That's going to just be enormous. Let's do -1. We do -1. That is going to give us -1 minus 3 plus 1 plus 3. So that all cancels and we get 0. So -1, 0. And so we found all the places that this graph is around. I know you hate me for like walking through that without a calculator, but I don't think you should touch the calculator unless you absolutely have to. All right, so there's that graph. The x-axis, okay, so we've got that. And then the vertical lines, x equals -1. So we're gonna start here. And x equals 2. So we're going to end here. So those are going to be our boundaries. It's nice when they kind of spell it out for you. Those are going to be the boundaries on your integral from -1 to 2. And we want from this graph to the x-axis. So that would be all of this. And then this part here, we're stopping at 2. So this is the area that we're going to find. Now I know when we did accumulation and everything we've done so far, this area down here below the x-axis counted as negative. When it just says find the area bounded by, you do treat them all as though they're positive. You just want the total area. Notice on question 2, actually in on question 1, we had this little bit that was below the x-axis. We didn't count that as negative. We just want this entire area. So this time we're going to need a calculator for this. We aren't going to do this one by hand. If I want all of this area from -1 to 2, and I want to treat it all like it's positive, what do I need to put around this equation if I want to treat it all like it's positive? Good, perfect, absolute value. So we're going to do absolute value of this equation. And this one, we're going to type in the calculator because we don't integrate an absolute value by hand. All right. So math 9, -1 to 2, absolute value of all of that. And it's going to take its sweet time here. Oh, there we go. Oh, actually, it wasn't too bad. So 5.750. You'll notice we're not putting units on any of these. That's because units aren't given in the problem. We are finding areas though. So if there were units, it would be like units squared. This would be like inches squared or feet squared or whatever. They typically aren't given problems like these, though. You just find the answer. All right, these last two, just as a heads up, these are going to be sideways problems. This whole thing is going to be horizontal. The whole thing is turned on its side, and they're going to be dy problems. I'm letting you know ahead of time because this is the first time you're going to see this. Again, people ask, how do you know? You kind of just need to look at it and see what you've got. But here's a big clue. This equation is x equals instead of y equals. The whole thing is backwards. That's a big clue that this is a sideways problem. All right, so let's graph this. I'm going to make a table of values because when it's backwards, that tends to throw people for a loop, and it helps if you just write it down. We're going to plug in for y and get x. The whole thing is reversed. So I'm going to always start with 0. I think 0 is the easiest number to plug in. If you plug in 0 for y, you're going to get 3. Now, when you plot that, it's still the 0.30. All right, we found it backwards, but this is still, you know, an XY coordinate plane here. All right, so let's try 1. Now, 1 or -1 for y, because you're squaring it, it's going to give you the same result. So I'm going to do plus and minus 1 at the same time. And then 3 minus 1 gives you 2. So we would have the points 2, 1, and 2, -1. And then let's do plus and minus 2. Again, I can do plus and minus because it's squared. So it's going to turn out the same whether it's positive or negative. Now that would give you 4. 3 minus 4 would give you -1. So those are the points -1, 2, and -1, -2. And here's our graph. Now, if you're sitting there thinking, hey, there's a problem with this, that's fine. What's the problem? Or I guess it's not really a problem with these, but what are you thinking? Because if you're like, hey, there's something wrong with that. Anyone want to share their thoughts? If you were thinking like, hey, there's something wrong with this, because usually there is. Usually this is like an issue. Like what would typically be the problem? Yeah, it fails the vertical line test. It's not a function. But we never said it was a function. It's just an equation. And those are allowed here. So you're allowed to have one. Oh, good, not a function. Oh, I don't care about your spelling. I'm a horrible speller. I'm like the worst speller in the world. I can spell like some math terms because I do that a lot in my job. But other than that, horrible speller, especially the word receipt. Does anyone else have a problem with that one? That actually makes me angry. There's a P in that word. All right, anyway. I don't care about spelling. It doesn't pass the vertical line test, but that's fine. We don't care if it's not a function. It's okay. Now, this is a line, slope of 1 that moved down 1. So we're going to start down 1, and then our slope is 1. So this is the area that we're finding. And the way you can tell it's a sideways problem. Oh, she said she spelled vertical wrong. And I was just saying like, that's fine, I don't care. Oh, the word I always make fun of is receipt. Like if you're gonna get a receipt for buying something, that word just like frustrates me with how it's spelled. Like I can never spell it without having to look it up. Does anyone else have a word like that? That's like always your struggle word? This is off topic, never mind. And I'm recording this too, so like I need to stay on topic here. All right, so this is a sideways graph. There's not a clear-cut winner for which one is above which one. Like this graph, the line is not above the curve for the whole time. Like it kind of gets split right here. But if you turn it on its side, here I'll color code. Do you see how this graph, make that be the blue one, is above this graph all the time? And I had some students that like just had the most horrible time with this. Like, Ms. Cole, I cannot tell which one's the right graph and which one's the left graph. And I finally just said, put an R and an L. That's right. This is left. And for some reason that worked. I don't know why, but it fixed whatever the problem was. So if that is an issue for you, just put an R and an L, right and left. Now, the first thing you need to do when you realize that it's a sideways problem is both equations need to be x equals. You have to make a full commitment to the entire thing being sideways. Now this one's already good. This one, we need to get x by itself. So what are we gonna do? You have to do some algebra here and get x by itself. And good, you're just gonna plus 1, all right? So it'll be y plus 1 equals x. So these are the two equations that we're using. And also when you go to do your boundaries, they have to be y values. So again, I'm going to throw that question at you guys. This time we're scanning downwards to upwards, and I want to use the y values. Any ideas what the boundaries are going to be? Here's your two intersections, but you need to use the y values of them. So it'll be good. Nice job, guys. So -2 to +1. -2 to 1. It's going to be the right graph minus the left graph. So the right graph is the parabola, that's the 3 minus y squared. Minus the left graph is the line, that's y plus 1, and then dy. Again, you have to make a commitment to the whole thing being sideways. You should never have x's and y's mixed together. These are y values for the boundaries. All of this says y, and then at the end it's a dy. All right, I'm going to go through this fast because I'm almost out of time here. If I distribute this negative, we're going to have a negative y squared minus y, and then this would be a minus 1, but I have a 3 there. So 3 minus 1 gives me 2. This is going to be negative 1/3 y cubed minus 1/2 y squared plus 2y, such that negative 2 to 1. And again, I want to have time to finish this last one. So I'm going to go ahead and tell you that if you do upper boundary minus lower boundary there, you're going to get 4.5, which is, oh my gosh, the exact same answer we got for this one, because it's literally the exact same graph turned on its side. Just wanted to make that connection. Do you guys see that? How it's the exact same thing? Whoa, crazy. All right, I have just enough time to finish this last one. Find the area bounded by, oh look, a huge clue. Both of these equations are x equals. This is going to be a sideways problem. All right, so x equals y squared. That's going to be a parabola that's just turned on its side. And you can make a table of values if you want, but this one didn't really get shifted around at all. It's going to be at the origin, and it's just going to go sideways like this. So we're going to have 1, 1, and then the, buy one, get 1 point. And then 4, 2. 2 squared is 4. And then 9, 3. And then 16, 4. I made this big enough that we could fit all the points on there. Again, it's not a function, but we don't care. It's an equation. We're just finding areas here, so we don't mind whether they're functions or not. And oftentimes for the sideways problems, they're not going to be, for the dy problem. All right, so here, let's make a table of a few points, just until we figure out what is going on. First, let's do 0. 0 is the easiest number to plug in. I'm going to plug in 0 for y. That'll give me 4 for x. Now remember, that's still the point 4, 0. So you still plot it as x, y. We're just finding it backwards. All right, and then let's try 1. If we plug in 1 for y, we're going to get 7 for x. So that's the point 7, 1. And if we plug in 2 for y, 2 times 3 would be 6, plus 4 is 10. We get 10, 2. Do you guys see how this is linear? I mean, this is a linear equation. And then your slope instinct can kick in, and you can just follow along with the slope there. And so this line is going to look like this. And then this is the area that we are finding. So I'll color code again. This is the right graph. And then this is the left graph. And hey, Ms. Cole, couldn't we do it as upper minus lower? I know it looks like the pink one is above the blue one, but it's not all the time. Do you see how right here it splits and the pink graph is not above the blue graph? You have to do it as sideways. If you tilt your paper, 90 degrees counterclockwise, now this blue graph is above the pink graph all the time. We're doing right minus left. So boundaries. Again, make a full commitment to the whole thing being a dy problem. What are they going to be? You guys have done really well on this so far. Scanning downwards to upwards, make sure you use the y values. This is going to be from where to where. Here are your intersections. Good, nice, good eyes. Nice job, guys. So -1 to 4. And then right graph minus left graph. So the right graph is the line, that's the 3y plus 4, minus the left graph, which is the y squared, and then dy. Again, these are y values. Everything in here says y, and then dy. So antiderivative, this is 3/2 y squared plus 4y minus 1/3 y cubed, such that -1 to 4. I'm going to do upper minus lower, and then I'll kind of just stop there since I ran out of time here. If we plug in 4, 4 squared is 16, divided by 2 is 8, times 3 is 24, plus 4 times 4 is 16, and then 4 cubed is 64. This would be 64 thirds for that. And then if we do -1, that's going to be 3/2 minus 4 plus a third. I believe in my heart that if you had to, you could distribute this negative and combine things together and boil that down and get a cleaner answer, but I ran out of time.